Checking the design, I already know there will be a lot of projectile and visual effects created and destroyed in a short play session. This is an issue because when you instantiate and destroy a prefab in Unity, it takes time and resources. With the number, it will add up and lower performances enough to disturb the player. To prevent that, I will integrate a pool manager. Instead of destroying reusable game objects like projectile, the pool manager will keep them stored in an inactive state. When I will need a reusable instance, I will just request the pool manager to give me one if possible, otherwise it will instantiate one for me. Let's start with the Poolable abstract class. An abstract class is a specific type of class that can only be inherited. Basically, a template for another class. This template can define a set of abstract or virtual properties or methods. Abstract keyword mean that inherited class must override the property or method in its own code. On another hand, virtual may be overridden, but it's not mandatory. So this template requires a pooling key getter to be defined. It must return a string that will be used as a unique ID by the pool manager in order to store the object in the right pool. It also requires a reset method. When an existing instance is returned by the pool manager, we want it to act as a brand new object. So we need to make sure to reset all possible existing state before using it. Finally, it does offer a dispose method. When I want to get rid of an object, I will call this method that will attempt to store it if there is space available. Otherwise, it will destroy it. Check with the following example that inherit from Poolable. As you can see, my code editor detects that Poolable is an abstract class and warns me about the mandatory properties and method to be overridden. Next, we have the pool manager class that is designed as a singleton. A singleton is meant to have only one existing instance at a time. I will include in my scene a game object with this component attached to make it effective. The instance will expose a pool size variable, which is the max number of stored instances sharing the same pooling key. It has a static instance variable that keeps a reference to the unique existing instance of pool manager, and a static dictionary that serves as a storage for our Poolable. On awake, this references the pool manager. In a perfect world, I would throw there if instance is already defined to stick with singleton design pattern. I then define two static methods. Generate method take as parameter a Poolable reference, a position, a rotation, and a transform. It first retrieves the pooling key from the reference. If the pool doesn't contain given key or if there is no available instance at key, it will simply return a new copy. Otherwise, it takes the first available instance stored, set its parent position and rotation, turn it active, and remove the instance from available list before returning it. Store method takes as parameter a Poolable object. It first retrieves the pooling key and creates that key in the pool dictionary if it does not exist yet. Then, if there is space available, it will store it. It takes Poolable as a child, so we make sure reference is not lost if another parent game object will be destroyed. We add it to the list of Poolable, call the reset function, and make it inactive. We return true to signify storing was a success, so Poolable does not destroy itself. Otherwise, we return false, so Poolable can be disposed.